All right, so sections 1, 3, and 5.1. I know we were just in 5.1. We're going to pick up a little bit more in it. So we're talking about formulas, linear applications, in 1 and 2 dimensions. Okay, so for some reason, you guys complain about numbers, but then we take them away, you're less happy. All right, never mind. Here, 1, ignore that. That'll be 2, 3. You get the idea. So here, we're going to go through and solve for r. S equals P plus PRT. Capitalization does matter. So if it's a capital letter versus lowercase, make sure you're catching that. To solve for r, I'm going to go through and actually work us through a similar problem first. And I'm going to make some space to do that. So if I had something like x equals 5 plus 5y times 3. If I had something like that. And I said solve for y. Well, this is just a big group of multiplication. And this is, and then plus 5, right? So if you're solving for y, most of you guys are pretty good about you're going to move the 5 over first. So you subtract 5 from both sides. Then you have x minus 5 equals 5y times 3. Well, how do you undo multiplication? Division, right. So the stuff we don't want over here. I want to leave the y, but I've got this 5 and this 3 that's a problem that are both being multiplied. So we're going to divide. That would all cancel. So you'd be left with this x minus 5 over 5 times 3. Now, I know that in reality we would go ahead and write that out as a 15. I'm just kind of trying to show that it's exactly the same when we come over here and do it with our numbers. So the first thing we did was subtract. So that's the first thing we're going to do over here. So subtract p from both sides. So now we have s minus p equals PRT. And then we have p times r times t. We're trying to just keep the r there. You guys already told me to undo multiplication, you just divide. So we're going to just divide by the stuff we don't want over by the r. We need to move the p and the t. So everything cancels here. And we end up with s minus p over pt equals r. There, number 2 that I moved. You guys go through and try to solve for h. Yeah, those are L's. So it's A equals 2LW plus 2LH plus 2WH. So that's actually the formula for surface area of a rectangular solid. All right, I'm going to go ahead and jump in. Like I said, this one was a little bit trickier than the first one. We're going to start off the same way, though, by adding or subtracting anything we can that doesn't have an H. So there's H in both of these, which means we got to move this. So we can subtract the 2LW from both sides. So we end up with A minus 2LW equals 2LH plus 2WH. All right, now we can't really just divide yet because we have an H in 2 parts. Any ideas how to get that H out of 2 parts? So what they're saying is basically we can just factor out the H. So we're going to end up with our the A minus 2LW equals H onto 2L plus 2W. Well, once we get it like this and we just have one H over on the right-hand side, what can we do? Yeah, divide by the parentheses stuff. So we're going to divide both sides by that 2L plus 2W. So we end up with A minus 2LW over 2L plus 2W equals H. All right, I'll let you guys try number 3 then. So B equals F over S minus V. All right, I'm going to go ahead and jump in. So what was the first thing y'all did for number 3? Multiply by s minus v. So it's the same as cross multiplying if you want to think of it that way, because that b would be over 1. So if we cross multiply or multiply both sides by s minus v, we're going to end up with b onto s minus v equals f. What was your next step? Okay, so distributing. Distributing is a perfectly fine option. You could have divided here, but I'm going to go through and distribute because I think most of you tend to do it that way. So to distribute, we end up with bs minus bv equals f. Yes, I know it's funny. So we're still trying to solve for s. What's the next step? We're going to add bv. So now we have bs equals f plus bv. Last step. Yes. Divide by b. So we're ending up with s equals f plus bv over v. Oh, gee whiz, over b. Let me fix that. There, like it never happened. Anyway, that's going to be a perfectly acceptable answer. I'm going to take this answer and tweak it. And all I'm doing is putting the b under both pieces. So it's still equivalent. But hopefully you guys see that over here the b's cancel, right? So then you are going to end up with the s equals f over b plus v. Either one should work. Oh, here? So just kind of the way that the fractions are going to work. If we have 1 plus 5, oh, I need to pick a different number, 15, 1 plus 15 over 3. Well, we know that that's going to be 16 thirds, which is the same as 5 and 1/3. So 1 plus 15, that's a horrible 15. Clean it up a little bit. So what you're trying to do is just reduce the 3 and the 15. You're trying to say, well, 3 goes into 15 5 times, so this is 1 plus 5. Anytime you've got a fraction, if you want, and there's more than one part in the numerator or on top, if you want to split it, you're going to have to take each top term and put it over the denominator. And if you forget, do a little quick example like this. It really wouldn't have mattered what numbers you picked. Is that okay? All right. Word problems. I know everybody's favorite. After a 30% reduction, you purchase a dictionary for $30.80. What was the dictionary's price before the reduction? First thing we're going to do, so I'm going to pick a variable, and I'm going to pick what it represents. So we're trying to solve for the dictionary's price before the reduction, or the original dictionary price. So if I have the original dictionary price, I need to reduce it by 30%, and once I reduce it by 30%, then I know it's going to be $30.80. I want you guys to take a second and see if you can figure it out. All right, so we're taking the dictionary, we're reducing it by 30%. So reducing it by 30%, is that adding, subtracting, multiplying, or dividing? Yeah, subtraction is going to be reducing. So we have the original price of the dictionary, and then we need to reduce it, which you guys just told me was subtraction, by 30% of the price of the dictionary. How do I write 30% of the price of the dictionary? 0.30, what? There you go. And you can't just put 0.3. I'm putting the 0.30 to make a point. So 30% is the same as 0.30. Yeah, so 30% of the price, so 30% times x. All right, and then after all that, we're going to get that 3080. Whenever I combine like terms on the left-hand side, what is x minus 0.3x? Yeah, 0.7x. Because there's the invisible 1 here, right? That trips a lot of people up because this is 1 minus 0.3. It gets a lot of people. 1 minus 0.3 is going to give us that 0.7. All right, last step. What is it? Yeah. So let's see. What is that? 40, 44? Is that right? Yeah. Is that okay? One of the ideas that was mentioned was to take 30% of the 3080 and add it back. The reason that doesn't work. So if you have $100 and you gave me 50% of it, you're going to be left with what? 50 bucks. Now let's say you got 50 bucks and I say, I'll give you 50% of your money back. I'm giving you 50% of your $50, right? So that got you to 75. It's because you're taking the percentage of a smaller amount. You're not going to get back to the original. So, all right, for number 2, we've got health clubs. So you're choosing between 2 health clubs. Club A has a membership for a fee of $40 and a monthly fee of $25. Club B offers membership for a fee of $15 plus a monthly fee of $30. After how many months will the total cost at each health club be the same? What will be the total cost for each club? All right, so the first question it asks us is after how many months will the total at each health club be the same? So the first thing I want to do is for us to write equations for each scenario. So for Club A and for Club B. Here we go. So Club A, it tells us $40 plus a monthly fee of $25. How do I write that? Yes. So 40 plus 25x. And now let's do Club B. Bless you. Club B has a membership fee of $15 and a monthly fee of $30. How do we write that? Yeah. Now you guys wrote that without even thinking about it. What does X represent? Yeah, the number of months. All right, super. Then it asks us, well, when are they the same? How do we figure out when they're the same? Yeah, just set them equal to each other, right? Whenever they're equal to each other, they're the same or they're equal to each other. So, to set them equal, all right, then we're going to go through and solve for the number of months. Again, I like positive x's. So I'm going to go to the right, so minus 25x on both sides. So we have 40 equals 15 plus 5x. Subtract the 15 on both sides. And we're going to get 25 equals 5x. So x is what? Yeah. So we have 5 as x. Or, for the first part, in 5 months, the total cost will be the same. All right, so that was the first part. The next part is, what's the total cost going to be for each club? How do we figure that out? Yeah, we're going to substitute that 5 in or plug that 5 in. In which equation? Club A or Club B equation? Both, either. It doesn't matter, right? They're the same. This is whenever they're equal. You can plug it into both to double check yourself. So for the second part, to determine how much, I'm going to pick Club A because it's the first one. So we have 40 plus 25 instead of the x. We're going to plug in the 5. So that's going to give us 40 plus 125, or 165. So $165. We could plug into Club B to make sure it's the same. I'll go ahead and let you know it is. Is that one okay? Yeah. All right. So let's look at number 3. So the length of a rectangular tennis court at Wimbledon is 6 feet longer than twice the width. If the court's perimeter is 228 feet, what are the court's dimensions? I'm going to give you guys just a second to fight with it. You could set it up as 1 or 2 variables. You could do it either way. All right, let's talk about it a little bit. So the length of the rectangular tennis court at Wimbledon is 6 feet longer than twice the width. All right, so we have a length here. We have a width here. It tells us the length is 6 feet longer than twice the width. How do I write 6 feet longer than twice the width? Nice. 2w plus 6 or 6 plus 2w, either way. The reason I was saying that you could use this as 1 or 2 variables, we have the L here, but we don't really have to use it because we've gone ahead and we're kind of doing the substitution all at once. So the court's perimeter is 228 feet. So that means that this side, which is the length, or it's 2w plus 6, plus this side, the w, plus the 2w plus 6 plus the w, or, if you remember that perimeter equals twice length plus twice width, that works too. So the perimeter being twice the length plus twice the width. Well, the width is just w. The length is that 2w plus 6. So perimeter equals twice, and then instead of the L, we're going to put the 2w plus 6, and then plus 2w. So 4w plus, plus the 2w. Now one thing I'm going to go ahead and do is I'm going to swap out this p, the perimeter, because it's telling us it's 228 feet. So 228 feet equals, and we're going to combine like terms. Yep. So the 228 equals 6w plus 12. We need to solve for w. The first thing we'll do is, subtract 12 on both sides. And we're going to get and then we're going to divide by 6, which gives us what? All right, are we done with the problem? No, because it says what are the court's dimensions. All we did was solve for the width. So to find the length, we can come back up and plug it in. So 2 times 36 plus 6. So length is what? 78? Yeah, so your answer is going to be the 78 by 36 or 36 by 78. So there's your real answer. All right, number 4 we'll do together. So we've got $7,000 that we're going to invest in 2 accounts. One pays 6% and one pays 8% annual interest. If the total interest earned for the year was $520, how much was invested at each rate? So to find the amount of interest, because we're talking about annual interest, it's just 1 year, we're just taking the principal or the amount that we put into each account and multiplying by the rate. The big trick is that the rate, whenever you're multiplying it to find out how much money you made, it's got to be as a decimal. So we couldn't just put 6 or just 8. So we're going to have the amount. We're going to have the rate. And the amount, that's also the same as P, same as principal. So then we'll look at it as P times R. And then we'll look at it as actual money in a second. All right, but first things first. We have to pick an amount. So we know there's going to be some amount invested at 6% and some other amount invested at 8%. What do you think we should call the amount we're investing at 6%? X sounds good. Now this one I'm going to go ahead and have us solve it using one variable. So if I used X of my $7,000 at the 6% rate, what's left for the 8%? All right, we can do Y, but I'm going to make you think for a second and not use Y. Let's say, so here, we're going to have a side note. All right, so there's 20 bucks. I give you 5. How much do I have left? 15, right? Okay, if I give you 10, how much do I have left? 10. All right, what if I give you 19? How much do I have left? 1. Okay, so however much I took out of it, how are you finding how much I have left? You're subtracting, right? So whenever I said that, okay, I'll give you 19, you all said, oh, well, then 20 minus 19 is 1. I said, well, I gave you 5. You go, oh, well, 20 minus 5 is 15. So we can do the same idea here. So there's $7,000 total. I just put X into one account. So the amount I have left, yeah, it's going to be that 7,000 minus X. Is that okay? Yeah? All right, well, good. You seem so happy about it. All right, we said that X was going to be our 6% interest rate. How am I going to write that as a decimal? 0.06. And the 8%? Yeah, 0.08. All right, so P times R, or the amount times the rate. We're going to have the 0.06. Well, I don't need it, but X. Sorry about the parentheses. I'm thinking about the next part. And then the 0.08 times 7,000 minus X. So algebraically, that's how I can put the amount of money I've made in each account. If I know I made $520 total and I've got this much information, what should I do next? Okay, so 520. Well, this will total up to 520 in a minute. This is more like our double check area. Yeah, so now we just want to find X. So what's 520 equal? Yep. Well, we're doing both because this is the interest of the 6% and this is the interest of the 8%. And I know the interest of these two accounts total gives us the $520. Very good question. All right, we'll set it up one more way in just a second. Maybe. How about we'll finish our notes and then come back and do it again a different way. Okay, so at this point, we're just going to kind of plug through it. So we have 520 equals 0.06x plus, we need to multiply here. Is that right? 560? All right, we'll combine like terms. So we have 520 equals negative 0.02x plus 560. And then we subtract 560 from both sides. So we're going to get negative 40 equals negative, and technically 0.02x. Those are equivalent. I can't remember if my math lab's a stickler about putting that 0 first or not. All right, and then just divide. All right, so we got 2,000 for x. So that means, so the amount we invested was $2,000 in the first one. What's the amount we invested in the next one? Yeah, $5,000. Oh, I do want to mention one thing before we come back to it. So one of the things that would have been really easy to do that I almost didn't write was forgetting that negative whenever you divide. If you got that you invested negative $2,000, does that make sense? Okay. If you have $7,000 total to invest, you know you're investing all of it, does it make sense that you would be investing $20,000 into an account? If you only had $7,000, investing $20,000 would be pretty impossible. Or skillful. If you can figure out how to do that, let me know. If you have $7,000 total and you figured out you invested $123 in one account and $926 in the other, that seem reasonable? No. Okay. The reason I'm bringing this up is I will have people miss these types of questions on the test, and it will be because you told me you invested negative money, or you invested more money than you were given, or you only invested $300 of the money you were given, or something like that. So just kind of go back through and make sure that your answer is logical for the scenario it gives you. Anyway, hopefully you'll be able to catch any silly mistakes that way. All right, let's do more. We're just going to set these up. We're not going to go through and actually solve them. I just kind of want us to get a little bit more practice with the solving part, or the setup part. So we have $11,000 in two accounts paying 5% and 8% annual interest. The total interest earned for the year was $730. How much was invested at each rate? All right, I'm going to go through and set this up the other way. So we're going to have account 1 and account 2. We're going to have the interest rate and the amount. All right. And we'll go ahead and use the two variables. How about that? So the account 1, what's the interest rate for account 1? Yeah, so 0.05. What about the interest rate for account 2? Yeah, 0.08. All right, the amount. If we use two variables, that's fine. Okay, we have x and y. And we know that if we take this 0.05x, multiply it, and then add the 0.08y, so 0.05x plus 0.08y, this is the interest at 5% plus the interest at 8%, is going to give us $730. Is that part okay? Okay. That was the hard part. The other part is the equation for the amount. We know the amount we invest in account 1 plus the amount we invest in account 2 is going to equal what? Yeah, that $11,000. So we know that x plus y is going to be the $11,000. And from there we could just use substitution, right? Yeah, oh yeah. All the methods we talk about as far as solving the equations, they'll all work. Some are just easier than others. For this one, I would probably solve for either x or y, and then just plug it into the top one. Is that okay? A new restaurant is going to contain 2-seat tables and 4-seat tables. Fire codes limit the restaurant's max capacity to 56 customers. If the owners have hired enough servers to handle 17 tables of customers, how many of each kind of table should they purchase? This is a lot of information. And I know for me, I'm sitting there going, oh, what are my variables going to be? If you can define your variables, it gets easier. We are going to use two variables. If you look at what they're asking, a lot of times that tells you what your variable is, like 9 times out of 10 probably. So it says how many of each kind of table should they purchase. Well, that's letting me know I need to solve for the number of 2 tops and the number of 4 tops. So x is going to be the number of 2 seat tables, and y will be the number of 4 seat tables. Which then starts to make it a little bit easier. So I think the really easy one is the owners have hired enough servers to handle 17 tables. So there's 17 tables total. What equation can I get from that? Yeah, x plus y is 17. So the number of 2 tops plus the number of 4 tops is 17 tables total. That makes good sense. All right, so we use this part. The other part is that we can only have 56 customers. So how am I going to figure out how many customers I can have? Yeah, so how do I write an equation that's dealing with the number of seats at the tables? Perfect. So 2x plus 4y is 56. So 2 people at every 2 top plus 4 people at every 4 top can equal 56 people in total. So one of the things that I do to double check myself is I make sure my units are the same on both sides of an equation. So in purple, we have tables on both sides, so number of tables, number of tables. And on the bottom, we're talking about people. So there's 2 people at each x table and 4 people at each y table for 56 people in total. Is that okay? Yeah, I think addition method would probably be great on this one. Just multiply the top through by a -2 or a -4 or something fun and add down. So we would go through, and if we wanted to solve it, we would just solve. We would tell them how many 2 tops and how many 4 tops. And part of the reason for wanting to label your variables like this is if you go through and you get x and get y, and you forgot which was which, or especially during a test, right, and we get a little stressed, if you reference back, you can make sure you're giving them the right variable, because they might have said, how many 4 tops are there? So then you got to pick the right number. So anyway, just a thought. All right, for C, a hotel has 200 rooms. Those with kitchen facilities rent for $100 per night. Those without kitchen facilities rent for $80 per night. On a night when the hotel was completely occupied, revenues were $17,000. How many of each type of room does the hotel have? I'm going to give you guys a minute or two to go ahead and try to set that one up on your own. All right, let's talk about it real quick. So I had to have 2 variables, x and y. What do x and y stand for? Yeah, so the number of rooms with kitchens and without. All right, so number of rooms with kitchens and number of rooms without kitchens. So my first easy equation is going to be what? Yeah, x plus y is 200. So the number of rooms with kitchens plus the number of rooms without kitchens is 200 rooms. All right, now we need to talk about money. So what's that equation look like? So $100 for every room with a kitchen plus $80 for every room without equals $17,000. So I've got my units the same on both sides. It's logical. Is this okay on setting it up? Yeah? Okay. All right, one more. Again, I'll give you guys like a minute and a half to get it set up. For D, really suggest drawing a picture. I will draw a picture whenever we work through it or whenever we set it up. So a rectangular lot whose perimeter is 360 feet is fenced along 3 sides. The perimeter being 360 means all the way around. So that 360 is all 4 sides. So there's your hint. All right, did you draw a three-sided picture? All right, so we have a rectangular lot whose perimeter is 360. So we actually, well, we won't write it yet. We'll read the whole problem. We'll be appropriate. 360 feet. It's fenced along three sides. And expensive fencing along the lot's length costs $20 per foot. And inexpensive fencing along the two side widths only costs $8 per foot. The total cost of the fencing along the three sides comes to $3,280. So it's telling us that we have two shorter sides, or two sides, the widths, that are $8 a foot. And then we have a length, but we only have one length. Did you guys catch that? Okay. All right, so the L and W are length and width, right? Those are our variables, what they stand for. So the perimeter is 360 feet. What equation do I get from that? If you put X and Y, that is fine and great. But if you put X and Y, you need to have somewhere that X is your length and that Y is your width. And like I said, again, this is one of those perfectly easy to goof up whenever it asks for what's your width. And then you just pick one of the two. All right, so we got twice the length plus twice the width is 360. Again, if you did 2x plus 2y is 360, that's great too. All right, now let's talk money. So we need to fence all the way around, and it tells us that it's going to be $8 for the widths, and that's going to be $20 for the length. And that in total it's $3,280. How am I going to write this? All right, I'm hearing a few things. I'm going to go ahead and write down two ways to write it with L and W, and then we'll talk about with X and Y. So with L and W, we can either literally just walk around this picture. So we've got $8 for every for the W, so 8W plus 20L plus 8W. So that's literally just walking around adding up the three sides, the cost of each side, equals the $3,280. We could be a little fancier about it because you know that we have two widths. So we could have said 2 and then 8W plus 20L equals the 3280. Either way, both of these are going to end up getting you to the 16W plus 20L equals the $3,280. And again, money, money, okay?